Man, this question was sent to me by a guy who had a tutor remotely. I can't see the question. I can't see if I say the question makes sense. Therefore, make a poster for here. Help one or two people. So the topic now from geometry. Geometry now simply about shape. Under geometry, at the under subtopic now mensuration. Mensuration now like measurement. So basically, we are measuring length and area. So the question goes like this. The figure below shows a semicircle in which are inscribed two equal semicircles and one complete cycle. Calculate the radius of the cycle. So now the figure be this. So this is a bigger semicircle, two equal semicircles and one complete cycle for it. Then someone could calculate the radius of this cycle. So wetin be radius? Radius is the distance from the center of a cycle here to any point at the circumference. Make I mark this radius r. Even if I should move from this point, if I move from this point to this point, this is another radius. If I move from this point, from this center again, straight down like this, I can call this one another radius, abi? So that's the radius. So Moku starts from question A, calculate the radius. The distance from this point to this point also, the radius, because now the center of this bigger cycle. I think it will be okay if I call am 4 centimeter. Why? Because half of it is 4. And from here to here is the half of distance from here to here. I will call am radius of the original semicircle. I still get another radius. You see, from here to this center here, I hope that is the center, will give me another radius for these two equal semicircle where they inside the original semicircle. So the distance from here to here, another radius, which is equal to the distance from here to here. This distance will be 2 centimeter, which is half of the radius of the original semicircle. So now, I will call this one third radius. I have how many radii? I have 3 radii. The one in yellow, the one in red, and the one in blue. See another one now. From here, come reach this center. Another radius of this semicircle where they inside the original cycle. And the distance is 2 cm. Let me draw this line from here now to this point. So I just connected this line now down to this place. Why? Because if this cycle now balances on these two equal semicircle, it means that the line from this center pass the center of this original semicircle. So we have said that here, from here to here is 4. That means that from here to the top here is also 4. It is also a radius. So from here down to this point, 4 centimeter. But if you look now, I don't get shape. I get triangle like this. So this triangle can't get curve like this. This side can't be the radius. This side can't be the radius. This side can't be the radius number thread. Now, this side now, and this side now. And then be these two. Now this side are 2. And this side equal to 2 cm. Now, what do you think say be the distance from this top? Can't reach this down. Because from here to here now, go be 2 plus this r where they here. From this curve to here, now 2. Then from this point to the top, now r. This side now will be 2 plus this r. Now I don't come out from this point to this point. I'm going to come out for here now. So wetin come be the length from here to here. So if I take away wetin I don comot, this one na the shape wey I carry comot be that. So as you see, na the r, first r wey I draw, abi first radius, na im comot, abi. If from here reach here, na 4, and then I comot r, then this distance supposed to be wetin now? Supposed to be 4 minus r. We don't get this length, we don't get this length, and then we don't get this length. This triangle they call a right angle triangle because this angle is equal to 90. This vertical line and horizontal line are perpendicular. That means they cross each other. So if you have a triangle that has an angle equal to 90 like this, you get yourself a right angle triangle. So why am I mentioning right angle triangle? Because there's a special property or properties about right angle triangle. The number one is that you can apply Pythagorean's theorem. If you are solving geometrical questions, you need your theorems at hand. The Pythagorean theorem says that this slant side we call am hypotenuse. So hype. This side down, we could just call am for time being adjacent. And then this side, we just call am opposite for time being. No. Pythagorean said the hypotenuse side squared could be equal to opposite side squared plus adjacent side squared. What it means is that I will take this value, square it, equate it to this value squared, and then to this value squared. We will say 2 plus r squared, that's all of the slant side or hypotenuse side, is equal to 4 minus r all squared plus 2 squared. Let's clear this bracket. The square of 2 is 4 plus this 2 times this 2, 4 times r, we have 4r plus r squared. This is how you open a square bracket. That is the addition of two numbers squared. This one will be 4 squared will be 16 minus, there's minus in the middle here, so I'll get minus 4 times 2 give me 8, then times r, I'll have r plus r squared. This one is called difference of two squares. Plus, I want to take the square of this guy now. The square of this guy will be 4 now. This is the left hand side, this is the right hand side. So we'll take away what is in the left hand side and take away the same thing from the right hand side. So this is the left hand side, there's 4 here, we throw it away and come here and throw this 4 away. There's r square here, we throw it away and come here and throw the r square, this r square away. Then what are we left with? 4r equal to 16 minus 8r. Now we collect like terms, so we have it as 4r plus 8r equal to 16. Then from here now I have 12r equal to 16. Then r is equal to 16 over 12. I'm dividing both sides by 12 now. So I have that r is equal to 4 here, 4 here, 3. So I have that my r, which is the radius that I'm looking for, is 4 over 3 centimeter or 1/3 centimeter. That's the answer for number A. Check. This video I no want make it long, so I will do another one for the number 2 answer. There's another method or some other methods of solving this question because we get plenty theorems that you can apply. If you get another method, make a note for the comment. Thank you and see you next.